So welcome everyone to NDC London. Hope you all enjoyed the keynote. My name's Stephen Haunts. I'm a book writer and I create courses for Pluralsight. Great to be back to in-person events. It's nice to actually see faces instead of little squares with initials in. It's very refreshing. So today we're going to talk about how product manufacturing can teach us to write better software. So we're going to be talking about things like lean software development, Kanban, and processes like that. So we'll start off just doing a quick discussion on agile ways of working, just a few minutes. Then we'll look at lean manufacturing itself, kind of the history of where that came from and how that's going to sort of lead into helping us write better software. Then we'll look at lean software development itself and some of the principles and values that we hold in that area. Then we'll take a discussion on agile versus lean and finish up on Kanban. Okay, so agile ways of working. So does everyone in this room work with Scrum, Agile, stuff like that? Put your hands up. Yeah, quite a few of you. Anyone still working in waterfall? Or has everyone managed to get away from that so far? So waterfall was, since the 70s, it's been traditionally how a lot of software has been built. So lots of big design up front, requirements analysis, then you eventually get to do the fun bit and actually write some code, and then you throw it over the wall to your testers, then they throw it over the wall to production, and then you hope nothing is broken. Of course, it's never as smooth as that. Requirements change part way through, and then you're just constantly going around in a circle, chasing your tail, never actually delivering anything. But then we came up with things like Agile and the Agile Manifesto. And what this did is it teaches us how to write software that evolves over time through adaptive planning, so change is our friend in Agile. If the business wants to change their minds, that is their right to do so. And as developers, we should embrace that. It promotes cross-functional collaboration and promotes the frequent delivery of working software into production. So those are kind of the things that we hold dear to us as software developers. So instead of a big bang all at once deployment, or big bang deployment every 6 months, it's teaching us to constantly write software, release it into production, and deliver that value to our customers so that we can learn from the software that we give them. Now, whilst a lot of us use Scrum, Scrum is just a project management template. There's lots of different ways of working. The thing that we actually care about is the Agile Manifesto. So I'm not going to go through the whole thing because there's lots of it on the website. But if you go to agilemanifesto.org, that's kind of the holy text of Agile, as it were. And that's kind of where things like Scrum and XP and all these different processes and project management templates kind of crept up from. So the 4 core values of the Agile Manifesto are individuals and interactions over processes and tools. It's more important to work with your customers, work and collaborate with the business, as opposed to worrying about whether you're going to use Jira or version 1 or a big board with post-it notes. Working software is more important than comprehensive documentation. So, in Agile, you don't do big design up front. You can still do documentation. Documentation is not outlawed, but it's about delivering working software as opposed to just trying to write a 400-page document that's out of date before you get to the end of it. Customer collaboration is also very important. It's about working with your customers, and your customers might be business sponsors as well. And responding to change over following a plan. So as I said before, if a customer wants to change their mind on how the software is built, say a legal regulation changes and you need to pivot the team, that's kind of one of the things that you embrace with Agile. So that was a whistle-stop tour of Agile. But what we really care about is kind of lean and kind of the things you can do on top of Agile to make our software development process better. So to do that, we're going to go back in time a little bit. And you're going to look at this gentleman here, so Henry Ford, who designed and started manufacturing the Model T automobile. And this was introduced in 1908. Henry Ford was quite instrumental in producing kind of continuous flow production lines. He was kind of one of the first people to really sort of get this right and do a good job of it. But what they had was what's called a push process. They had a very efficient production line, things flowed through the line and you ended up with a car at the end of it. But what they had was called a push process, where the company itself sets their own demand. So they might say, well, we sold 5,000 cars last month, let's make 6,000 this month. And they manufacture all these cars and hopefully they'll sell them. Whereas a pull process is something that is set by customer demand itself. So, a customer wants to buy a car, you manufacture the car and give it to them. So your manufacturing process is determined by the demand of the customer, not an arbitrary set of numbers set by the company. Of course, Ford being very adventurous, they did manufacture far too many cars, and there were just lots of these cars left on parking lots at the Ford Motor Company, just basically rotting and going to waste. And in post-war Japan, two guys from Toyota, so Koichiro Toyoda and Teiichi Ono, visited the Model T plant in America because they wanted to learn about how the Americans were building cars. But when they were there, they were not really impressed with what they saw, basically for the reasons that we just said about it being a push process led by, arbitrary numbers, as opposed to being a pull process. What they were impressed with is when they went to visit a supermarket in the US, just a normal supermarket to buy groceries. But what they were impressed with was how the stock ordering or stock reordering process works in a supermarket in America at the time. So you have products on the shelf, say toothpaste, for example. Products start getting lower on the shelf, so an attendant restocks the shelf. When the number of, say, tubes of toothpaste goes below a certain limit in the warehouse, you do an order from the manufacturer to get some more in. So you've got this continuous flow of products going through your system. So you should ideally never go out of stock on a product because you're constantly replenishing based on that customer demand. And this was kind of the part of the trip that interested them the most, and this kind of got them to come up with something called just-in-time development, or just-in-time process. What a just-in-time process does, it helps lead to a lack of inventory in your warehouse. So if you have inventory in your warehouse, you've got to pay for the storage of that inventory. The inventory can deteriorate over time, and it's just generally expensive. So these are all things that are considered wastes. So when they were coming up with just-in-time, they did actually identify a whole series of wastes that they want to try and eliminate from the manufacturing process. So some of these might, seem quite familiar. So defects, for one, is bad. If you manufacture a car and it's got a problem, the customer's going to bring it back and want it fixed. If you have a major design defect, like a problem with the brakes, then you're going to have to recall that entire product line back to a service centre to be fixed, which is hugely expensive. So you want to stop defects from happening before they go out, just like we do with software. Overproduction, again, a byproduct of that push system. So if you produce too many cars or whatever it is you're manufacturing and you can't sell them, what do you do with that overproduced waste? It's going to deteriorate over time, especially with a car. I mean, if you've got rubber seals and stuff all over the car, that stuff kind of breaks down over time. So you either have to scrap it or sell it off cheap and make a loss. Transportation is a waste. So if you have to transport products from different sites, that's obviously bad. You want to try and think of how you're going to optimize a factory workflow process so that everything is in the right place at the right time. Waiting was another waste they wanted to eliminate. So if you have a manufacturing process and then suddenly you run out of widgets on part of the process and you have to wait for someone to bring it over to you, then that's obviously bad and it stops the production process. Excess inventory, so the parts that you use to build the car. So if you've got, you need to build 3,000 cars, but you've got 5,000 steering wheels in stock, then you've got to store that excess inventory, which is a waste. Motion, which is kind of like transportation, but finer grain. So if you think about the layout of a factory, and over this side you've got shelves with lots of widgets and bobbits on, but you need them over that side of the factory for that part of the production process. Someone has to go take them off the shelf, put it on a cart and wheel it over there, which is excess motion. Or you could just move that rack from there and put it over there nearer the place where it's actually needed to reduce that motion. Kind of a very simple optimization that can actually have quite a big effect in a factory. Processing, and what this means is kind of over-processing. So don't do more to the product than what the customer actually expects. That's kind of classed as over-processing. We call that over-refactoring, when you refactor a piece of software to death more than you actually need. Not saying refactoring is bad, it's good, but you can go over the top, and I'm sure we've all been there. I know I have. And the final one was the underutilization of people. So in any organisation, the people that you employ or the people that you work with are the company's biggest assets. If you underutilise them, not only are you paying a high salary for someone that's not being fully utilised, if someone feels like they're not doing enough in their job, they get bored and want to move on. So all that investment that you've put into training that person up will suddenly go out the door and they'll probably go to a competitor. So underutilisation of people is a big one, and we're going to focus on that a bit more later. So when they were coming up with their just-in-time process, they come up with 4 lean principles that they wanted to focus on. So the first one was value. Everything is about value, giving value to the customer. If what you're doing isn't serving the customer, then what's the point? Everything is about the people that are buying your products. One of the principles they came up with was the value stream, which we're going to look at in more detail in a moment, so I won't focus on that yet. Flow or continuous flow is about making sure that your manufacturing process is constantly moving. You don't want to have a blockage in one part of the manufacturing process because it holds up pretty much everyone else on the production line. And trying to restart to stop the production line is more complicated than what you'd want. And also the other principle was perfection. So everything is about making sure that product is perfect for the customer. So that's kind of where we're coming from with lean manufacturing. So if we look at lean software development, this is kind of like the next evolution of this, which is kind of what we care about as software practitioners. So there was a book that was released called Lean Software Development and Agile Toolkits by Mary and Tom Poppendick. Brilliant book if you've not read it. If you're looking for a nice hot read for the pool this summer, maybe not this one, but it is a good book. It's a big book. And what they did is they looked at this kind of manufacturing process from Toyota and the history of manufacturing, and they tried to think, well, how can we apply this to software development? Because there's a lot of similarities in what we do. I mean, we may not be making machines necessarily, although your company might make machines, but the software you're writing isn't necessarily going to turn into an automobile. It's going to be a blob of code on some server somewhere. So how can we apply this? So they came up with their version of the list of wastes, the kind of things we want to eliminate from our software development process. So again, defects, I think that stands for itself. We want to stop defects before they reach production. We have lots of ways of doing that: pair programming, test-driven development, automation tests. That's kind of our toolkit that we try and work with. Extra features that you don't actually need. Now, we're all guilty of doing that, especially if you're building a framework. You throw everything in there, including the kitchen sink, because there might be some obscure use case that you might need in 12 years' time, which you never do. So you end up writing far more code than you actually need. You've got to maintain that code. You eventually leave the company, and some poor bugger's got to maintain that code, which you invariably haven't documented in any way. So extra features is a waste. Handoffs, and this goes back to like things with waterfall, where you're constantly having to hand off deliverables between different stage gates, whether it's a documentation, or whether it's developers handing code over to QA. That handover process is expensive, it's complicated, it never works too well. I mean, back in the day when you had to write 12-page documents to give to the ops team so they could deploy some software before we had all these fancy automation tools, those kind of handoffs are very wasteful because invariably things go wrong. Things don't get documented very well. Everyone hates writing documentation, so you tend to be a bit lax on some of the instructions. Not that I've ever been guilty of that. Delays, obviously, is a waste. Any delay comes into your software development process, which stops you from delivering software to your customer. That's wasteful. Partially completed work. Unfortunately, everyone has to suffer from this at some point, but you start working on something and then your boss says, nope, I need you to do this instead, it's more important. And that thing you was working on, you either come back to it months later or you never do. It just ends up languishing in software development hell. Finer grained part of that is task switching, the bane of every software developer. You're working on something, you get disturbed at your desk, even though you've got your headphones on, which means go away. People still disturb you, you end up having to do a complete cognitive switch to look at something else, and then it takes you half an hour to get back into what you was doing before, which is kind of wasteful and tiring as well. And the final one, which was unneeded processes. So inventing software development processes just for the sake of it, just because it's fun and we like building processes. So those are the 7 wastes that Mary and Tom came up with. So that was their version of the lean manufacturing wastes, but for software. And then they came up with 7 principles, and this is what we're going to spend some time looking at, these different principles. So value stream mapping, building quality in, amplifying learning, deciding as late as possible, delivering as fast as possible, empowering the team, and seeing the whole. So when you read that massive, like 900-page book, basically they're distilling it down into these processes. Obviously they have more examples. So the first one is value stream mapping. I put this first because it's one of my favorites. And value stream mapping is a diagramming and documentation technique that you can do as software developers along with the business. It's a really good collaborative exercise you can do with your business. And what a value stream map does, it maps out a business process from start to finish, and you record what parts are giving value and what parts are not giving value. And then you can work out an efficiency score based on that. So I've got an example from a company I worked at many years ago. It was a retail lending company, it's a finance company. And part of their decisioning process for a loan, it was manual. So the customer had to fill out a paper application form, send it off, and then people had to do stuff to decide whether you could have that loan. So it's a very manual process. So I don't know how crazy that is to see, but the process kind of looks like this. We've got the process running along the top, and then we've got a chart underneath of value add and non-value add time. So we can see the customer applies for a loan. That might take them half an hour to fill out the form and pop it in the post. Then with the postal service being what it is, that might take 3 days for it to arrive at the finance company. Someone has to open it, someone has to file it, put it in the correct queue for someone to look at. That could take up to 3 days. Kind of using worst case scenarios in these examples, because I think they're more interesting. Then a loan decision is made by someone looking at the form. That might take half an hour to do the relevant credit checks and ID checks and whatnot. Then it goes into someone else's queue, and if they're busy, that might languish for so many days. I've said 3 days here. Then the loan agreement is received, and then it's all filed. It then gets posted back to the customer. That could take a day for them to receive it and sign the documents. Then a loan disbursement is requested. That could take half a day. It's dispersed. Then the customer gets their money in the bank. So if we look at this, so the cycle time, so from the customer filling out that form to the money landing in their bank account, in this case, was 8 days, 207 hours. Which, going back to old ways of applying for loans, that's actually quite fast for the old days. So the value added time, where people are actually doing valuable stuff to make sure this customer gets their money, is about 3 hours. It's about 3 hours work going on there. But the non-value added time, waiting for postal services, things sitting in queues for people to work on, is 204 hours. So from that, you just divide the value added time by the cycle time, and you get what's called a process cycle efficiency score. So in this case, it's 1.4%. But we don't need to calculate a score to know that this is very inefficient. We can see 3 hours out of 207 of value added time. So software developers, we work with business analysts, people in the business, and we try and work out a better process and try to digitize this process. So we end up with something like this. So the customer applies for a loan online. Might take an hour this time because we're asking for a lot more information to do affordability checks. That will get put into some RabbitMQ queue somewhere, or whatever fancy queues people are using these days. It then goes into a credit check process, so Experian, Equifax, that sort of thing. That could take a quarter of an hour for all that to happen, worst case scenario. Goes into another queue, then ID checks happen, which happens quite quickly. And then something is sent back to the customer for them to digitally sign the agreement. That could take, what I said here, a few hours, because they're not necessarily going to respond to the email straight away. And then once that goes back, the loan's dispersed, it ends up in their account. So if we look at the scores on this process, so the cycle time is 8 hours in this case. So from them filling in this online application form to them having an agreement made that they sign and money being dispersed is 8 hours. So 2.5 hours of this is good value added time where stuff's actually happening digitally, but it's valuable stuff. And there's a lot of non-value added time, 5 hours. So the process cycle efficiency on that one is 31%, which is better. It's much better than it was before. But the good thing is, if you implement this process, you can then look at how would you optimize this process further still, and it gives you something to look at and a piece of documentation which helps you see that system or that process so that you can work out how to improve on it next time round. And when you build these kinds of maps, you don't just build one for one process. You might build several for different cases. You might have a best case scenario, worst case scenario. You might have edge cases where maybe you've done a credit check, but their ID check doesn't return correctly, so you need to refer it and speak to them. So you might have all these different processes in there. So you build up a suite of these documents. I think it's very good. I've always enjoyed producing these sorts of diagrams because it helps you understand the development process. Just imagine how brilliant it is if you go to a new company and you get thrown into this team doing loans or loan servicing. It's like, well, I need to understand how this process works. So they give you some link to SharePoint, and there you've got loads of value stream maps to document the process. Imagine how useful that is to a developer when you start. It encourages lots of collaboration because you're not going to be able to do this diagram by yourself because you're not the subject matter expert necessarily. You're not the business. So it forces you to go out and talk to people, talk to the business, which some people may think is great, some may see that as a bad thing. But overall, the message is that encouraging collaboration with our business partners to document these things is a good idea. But also from the business point of view, it helps them really understand whether they understand their processes. Because you'd be surprised in a lot of companies, you get people in the business who don't fully understand their own processes. They might understand the bit that they deal with day to day, but they don't necessarily understand the whole process. So for them, this is actually very valuable as well. Okay, so that's value stream mapping. So the next one was building quality in, and this kind of takes many different facets. So the one we probably deal with as developers the most is, what we do to the code before it goes out into production. So we might do things like pair programming. Some people might do mob programming. It's quite fashionable at the moment. Test-driven development, automation tests, that's kind of how we as developers look to build quality into our code. Yeah, refactoring, all those sorts of things. Another area that's important is sort of monitoring, logging, and telemetry. But the vast majority of companies that do good monitoring and logging are doing it for reactionary purposes. They want to know when stuff breaks so that you can then go and fix it, which is good. You should have that. But if you capture really good time series logs of all of the events that are happening in your software, you can learn from it. You can learn how the system's performing. And if you're really efficient and you've got really good logs, you can actually work out that value stream map automatically and actually have a dashboard that shows you the value stream in real time of products going through your system, which is brilliant. So another finance company I worked at, we actually built this. We had a map on the screen, and throughout the day we could see how many customers applied for loans, how many had been accepted, how many had been rejected, how much money had gone out. And we could look at debt calculation scores for the company as well. And we could actually use that as a way of optimizing our process, which is brilliant. Another way you build quality might actually be in the software itself. And I've got an example of this. I used to work for a retail pharmacy company in the UK. I'm not going to say the name because we're being filmed. But I was a development manager in their pharmacy division, and we were looking to replace all of the pharmacy computer systems in our stores, because every store was kind of their own hub, and then everything got fed back to head office overnight. So it's very hub and spoke. So we wanted to make it more of a centralized, modern pharmacy dispensing system. So the bit I was working on was where we take some data from the NHS. Does anyone here work in healthcare? Yeah, so you're familiar with the Dictionary of Medicines and Devices? Okay, so Dictionary of Medicine Devices, or DM&D, is a data set you get from the government, and it talks about, if you've got this drug, you've got all these different variations of it, and it's basically the canonical list of types of drugs that you can dispense in the UK, and devices, so like asthma inhalers, pumps, that sort of thing. And then also we get products catalogues from all the different drug companies, so Pfizer, GlaxoSmithKline, those sorts of companies. Now, those two pieces of data need to be married together. So we had a master data management system that we built in-house. This is before some of the really big fancy ones that you can buy on the market. Now, it sounds simple in principle. We've got drug data, we need to apply it to this list of things that the government, the NHS says that you can dispense. If you get it wrong, so if the way it would work is doctor would say prescribe paracetamol. Then at the point of dispensing, the system would say, well, we'll give them either this brand or this brand, depending on what deals have been done with the pharmacy companies. Which is why sometimes when you go get drugs from the pharmacy, you might get different brands dispensed to you. So these things have to be mapped together. Now you imagine if you map the wrong drug to the wrong thing in the Dictionary of Medicines and Devices, and some poor pharmacist dispenses you the wrong thing, what's going to happen? Well, you can get ill or you could die. It's kind of a failure case we don't really want to have to handle. So by building this system that marries these systems together, we had an automated process that tries to do its best to map these drugs together based on previous matchings. But then we had to build in what was called a maker-checker process. So this system was used by pharmacists at the head office. So you'd have one pharmacist go through and approve all the matches. Then it would go into another state where another pharmacist has to go and re-approve the work that they've just done. So one person makes a change, the other person checks it. Yeah. Now this was part of the software. It was part of the thing that we deployed out to this team, which is another example of how your products may actually have safety protocols built into it to ensure that you deliver value to the customer. And in this case, the value is not killing them, because that's bad for business. So the quality controls can actually be a part of the software feature set as well, which is basically what I'm saying. Now, one of the ways we improve our software is by continuous improvement. So, we very rarely deliver something into production. It's perfect first time. We make it good enough, and we hope that we get feedback from our business sponsors or our customers, and we try and make it better. That's why things like Scrum work so well, because we're constantly giving out pieces of software. But when you're trying to work out how to improve software, there's a couple of different methods you can use. So you might have heard of them. So the first one's called the Deming cycle, or plan, do, check, and act. This is a very simple process you go through to try and work out, or try and run experiments in your system to work out what needs improving. So first of all, you come up with a plan. So it's a bit like the scientific method. So my hypothesis is if I tweak this thing over here, I'm going to get improved efficiency over here. So that's your plan. So you do it, you run an experiment. So you put this change into production, everyone agrees. You look at the results through your logging and telemetry. You then check the results, and maybe you run this experiment for a week in production, testing in production, great. But you look at the results, and if it does what you want it to do, you make the change permanent, you act. If it doesn't do what you want to do, you might put that feature back, and then you come up with another plan. So that's called the Deming cycle, and it's just a great way of continually trying to improve things in your software. The other one is 5 whys. If anyone's got children, you're probably brutally aware of this, because that's the way children learn to navigate the world, is by asking why all the time. Tidy your room. Why? Just do it. Why? And I found a really good example of this. I didn't write this. It's from that link at the bottom of the page. It's a very good example. Again, it goes back to manufacturing, and this one actually has 6 whys, just to show that you can have as many whys as you want. But what you're effectively trying to do is get to the root cause of a problem. It's root cause analysis. So in this example, we have the conveyor belt on the main production line has stopped working. Okay, well, why has the conveyor belt stopped? Well, the main pulley responsible for rotating the belt is not functioning properly. Okay, interesting. So why is the main pulley not functioning correctly? Because it's not getting enough power from the motor. Okay, well, why? Because the motor has stopped working. Okay, well, why has the motor stopped working? Because the motor windings have burnt out. Okay, well, we're getting a bit closer to the problem here. Well, why have they burnt out? Because the motor was loaded beyond its power capacity. Okay, well, why did that happen then? Because the instructions about the motor's maximum load weight were missing. So that is kind of the root cause. So the reason why this conveyor belt has stopped working is because there were some missing instructions. So people didn't know how much they could load onto these motors. So that's all the 5 whys is. You're just constantly asking why and trying to dig down into a problem to get to the root cause. Okay, so the next of the Lean software principles is amplifying learning. And this is all about using your software that you have in production to try and learn about how to improve it. A bit like what we've just spoken about, but it's about getting rapid feedback. So again, it sounds very much like Scrum, doesn't it? You develop some software in a sprint, you put it out, you learn from your customers, and you constantly iterate. And there's a brilliant example of this with SpaceX, or when you compare SpaceX to NASA, for example. So when you look at NASA and how they run their kind of shuttle program, it's all very big design up front, lots of different vendors, lots of architectural diagrams, safety checks, you've got multiple vendors building the same system, so you've got redundancy in the system. It's all big design up front, and then eventually you have this thing that you can fly, and hopefully it works. Unfortunately, as we've seen, the shuttle program did have its problems and failures and fatalities. Whereas you look at a company like SpaceX, they took a completely different approach in how they developed the Falcon rocket. So they built a rocket, they launched it, it blew up. They looked at the data, figured out why it blew up, built a new rocket, sent it up, that blew up. And they constantly did that. And eventually, after I think it was about 4 or 5 goes, they had a rocket that would go up into orbit, the second stage would come down and land on something that's equivalent size of a postage stamp, like a barge in the ocean. So how cool is that? And they did that just by constantly iterating. So they were never putting safety. They were never forgetting about safety. Obviously, people were never on board these rockets. They built these rockets, they got them working. They eventually started launching satellites. Then eventually they were allowed to deliver cargo to the International Space Station. They did that for a while. And it wasn't after years and years and years and years of this testing that they eventually put 2 astronauts on the other year and took them up to the space station. Now they've done that multiple times. And they've even started sending civilians up into space as well, which is quite remarkable. It just goes to show the different process that they took to NASA. So NASA's a big government-funded body, lots of red tape and process. Whereas you've got a plucky little startup company comes along, builds a rocket, lets it blow up, and then just learns from that initial mistake, which I think is a pretty cool example. I'm a bit of a space nerd. I love the whole SpaceX thing. It's pretty cool. So the other example then is deciding as late as possible. And this is all about deferring decisions as late as possible so that you don't get blocked, which is quite important. I've got an example of this. Again, I've worked at quite a lot of finance companies. So one that was working out was going under a lot of government review at the time. A lot of regulation changes were coming in that we're trying to deal with. So we wanted to change the way in which we assess the affordability of a customer for a loan. Now, part of that is through credit scoring, so Experian, Equifax, those kind of services. But then we get data from that, and we have other information that we know about the customer, and that goes through something called a scorecard. And that scorecard, you have 10 different results that can come out the back of it. Sounds kind of simple in process. Pull some data in from different sources, do some decisioning, have 10 possible results that come out the back of it. And the problem was, because we was going through a government review at the time, and kind of a financial services review, there's a lot of scrutiny over how these calculations are taking place and how we're assessing the customers, which means you've got regulation bodies getting involved, you've got legal teams, lawyers getting involved. And as everyone knows, as soon as you get lawyers involved, you can get any estimate and times it by 50, because it just takes forever. Now, as a software development team, we still had to build this system. We had hard dates which this thing had to be out by to hit regulations. So we couldn't just stop and wait for all these decisions to be made. So you do what any software developer does. You abstract it and you start building stubs. So we know what data's going into this thing. We know what the 10 results are that can come out of it. So we just built test harnesses. You could drive different pieces of data into it and you get certain responses out. So for the vast majority of the system development process, we just had this scorecard stub working in there. We just deferred that entire bit until later. And then about 3 weeks before we're supposed to go into production, the scorecard process was signed off, we implemented it, tested it, and then deployed it. So it's quite a simple thing, if you haven't got the information, do something else until you do get the information. It's basically what that meant. Okay, so delivering as fast as possible, we don't really need to spend much time on that one. The quicker you get software into the hands of your customer, the faster they're going to get value from it, because it's all about value. The faster you'll get feedback so you can improve what you've done. So we don't really need to dwell on that one. And the last one is empowering the team. Now, this is quite important because certainly in organisations I've worked in, that I've consulted in, a lot of developers, and I class everyone in the development team, not just the programmers, sometimes feel a bit as though they're not really empowered to make decisions for themselves, which is a real shame because development staff are expensive. People are on generally quite good salaries. It's a lot of money that the company's outlaying. So you think for that money, you actually want to empower your team to make decisions within the organisation or within the remit of their team. One thing I find is if a team doesn't have or doesn't find meaning in the work that they're doing, then they eventually get disgruntled. And then once you're disgruntled, you start looking for another job. So from a company's point of view, certainly in companies I've worked at, you always aim to try and get 2 years of value out of a member of staff before you hit what you class as some kind of imaginary break-even point on the training you've given them. So if they don't have meaning in the work that you're doing, then they don't, the microphone gone funny there. And if they don't have meaning in the work that they're doing, so they're going to get disgruntled and leave, which is bad. So another example from one of the finance companies I worked at was we had this little project that we were given. Small team that put together was going to run it like an internal startup. So it was given a lot more freedom than what the normal software development processes would allow. And what happened was we spoke to the debt collection team, and the woman that ran that team was quite forward thinking. She was very good, and she was worried about the fact that we're lending money out to people and they're just not paying it back. The age-old problem in financial services. And in a lot of collection companies, you get customers going to different cohorts. You've got people that are up to 30 days late in paying, 60 days late, 90 days late. And when you get to 120 days, that's normally when you're sold off to a debt collector. And you get someone knocking on your door trying to take your TV. So she wanted to come up with an alternative way of trying to get these people to pay, because a lot of them just won't answer the phone. Well, why won't they answer the phone? Because they're in debt. They don't want to have that awkward conversation because it's not a nice thing to have to deal with. If you've come into some kind of financial hardship and you can't make a payment, it's, you don't want to have a conversation with someone about it necessarily because there's a stigma associated to it. So we're like, well, is there anything we can do to help these people pay, but not make them feel bad about it? So we set up a small team, developers, designers. This is not an actual screenshot, this is just my rubbish approximation. And we're like, well, let's set up some kind of website that we can direct the customers to via, I think it was SMS at the time, and email. Compliance and all that were involved in this. It's like, well, let's authenticate them on a system. We'll tell them what their balance is, but we'll give them a slider. And we'll say, if you pay anything on that slider, we won't contact you for 30 days. So at the bottom, so this example here is the customer's £350 in debt. So we have a slider that starts off at £5 and goes all the way up to £350. As they moved the slider, we actually displayed positive reinforcement messages by saying about, if you pay this amount, you'll save this amount of interest overall on your loan. So it's all about sort of positive reinforcement. So we built this in, I think it's about 6 weeks from start to finish just to get something out there. So we run it like a small startup. Probably one of the most fun projects I've ever worked on, if I'm honest. It was really, really fun. We had a target cohort list of customers we wanted to target. So we started with the people that were up to 30 days late. So we sent them messages. We tracked when they were coming into the website and whether they made payments or not. And we did this all the way up to the people that were about to be sold off to debt collection agencies. So the people that are in the most trouble. And the results were interesting. So loads of people just came in and made small payments. These are people that we've tried to phone and haven't picked up the phone because they just don't want to talk to you. So these are non-contactable customers as far as we're concerned. So some people just made small payments to stop us from phoning them. That was good. But then we started noticing a trend of actually people making larger payments. Some of the people that were about to be sold off to a debt collector actually cleared their debts, which was interesting. So when we kind of looked at it as a whole, it's like, well, why would they go and do that when we've been trying to get them to do that all along? Well, it's because they didn't have to have an awkward conversation. We put the ball in their court, as it were. We gave them, we empowered them to make their own decisions about trying to clear off this debt without them having to worry about the stigma of being in debt. It's hugely fascinating, kind of looking at the psychology of it. This is kind of one of the things I was talking about, empowering the team. So we built a small team together. We kind of discussed the mission of what we were trying to do. We were genuinely trying to help people that got themselves in trouble. And we're trying to help them get out of trouble. Now, I don't know about you, but I found that quite empowering to know that we're actually trying to help someone that's kind of got into a bad scenario. So key message there is, empowering the team, giving them meaning in what they're doing is kind of hugely beneficial. And it keeps staff at a company. If you believe in what you're doing and you enjoy it and you feel empowered to make decisions, so you're not just being told what to do all the time, you're more likely to stay with an organisation, which is good for that organisation because they're getting more value out of you. Okay, so the final one is seeing the whole. And this kind of goes back to really full circle to the value stream mapping concept. So it's very easy to, especially as technical people, to try and optimize a process, but you just focus on one small piece at a time. And you think, well, if I change this, it's going to have a massive impact. Or if I change this one small thing over here, it's going to have a massive impact. What seeing the whole is trying to do is it's trying to get you out of the mindset of doing small micro optimizations, but kind of looking at that process as a whole and understanding how your whole system is working. Because sometimes the smaller optimizations over here might actually give you a bigger benefit overall than just trying to micro optimize one small service. So that's where value stream mapping comes in, but then using logging and telemetry as a way of trying to see how your system's running. So I think there's a big untapped market. Is anyone here doing machine learning or interested in machine learning? I mean, what if you start building machine learning models around the telemetry data that your system's producing, and then start asking that questions about how we can improve our system? I think there's quite a big potential there, which could be quite interesting. So not necessarily looking at big data of your customers, but looking at the big data of your system as it's running, trying to work out what's going on. That's kind of what seeing the whole is all about. It's kind of looking at the system all together and using that as a way of learning how to improve. Okay, so we discussed Agile at the beginning. We spent a bit of time on Lean. But one thing you might be thinking is, are we supposed to be doing Agile? Do we now switch to Lean? Is Lean the kind of the new thing? So we've already looked at a lot of the benefits of Agile. It's rapid delivery, focusing on people and interactions, attention to detail, simple design, early returns on investments. These are all the things that we covered earlier on. So those are our Agile benefits. Lean development benefits is, eliminating waste leads to more efficiency, delivering early or delivering value sooner, and empowering people to make decisions. So those are kind of the things we care about with Lean. So, which one do we focus on? Well, the simple answer is both. So Scrum and Agile is a value driver software development framework. I mean, people use Scrum in different ways, and you've got the people that take the Scrum manual and treat it as a holy text and don't ever defer from it. And you've got people that, will use Scrum as their basis, but then adapt it to their organisation as they see fit. Either's fine. But Scrum is effectively a project management framework that you work within, whereas Lean helps you optimize its process and optimize the process of your systems. So these things actually go hand in hand. So if you've got a well-established Scrum or Agile process within your organisation, and it's kind of ticking along nicely and you're delivering value to the customer, you can then start looking at the next level with Lean and start looking at how you can actually optimize your entire process over time. Now, Kanban is also something that's quite popular, and Kanban works really well with Lean because it is a pull method. Now, I'll talk about Scrumban a little bit later because a lot of people use this with Scrum. But Kanban is originally a process that helps you do a pull system like Lean. So it's constantly a continuous flow of tickets going through your board. And one of the things we do with Kanban, if you're using it as it's originally defined, is you set up what's called work in progress limits on your board. And this is in hugely valuable if you're not doing this. So if you do Kanban but you don't do WIP limits, this is very valuable. So imagine we've got a very simple board. So quite simple: to do, in progress, code review, QA done. Quite a simple board. You then look at the size of your team and the capacity that you've got, and you set limits at the top here. So we've got to do, we can have a maximum of 2 tickets in this column. In progress, no more than 4. Code review, no more than 3. QA, 3. And then obviously done is when you deploy it. So the team's working away and the board looks like this. So everything looks okay at the minute. Tickets are flowing through the board nicely. Then we get to this point. So can anyone see a problem with this board? Okay, no one's willing to speak out, that's fine. So if you look at the code review column, it's got 3 tickets in there, but the limit is set to 3. So that's given us a big visual indicator that we've got a problem brewing. So we set a capacity of 3 and we're already at that capacity. Now, if we breach that capacity, then the QA finishes his ticket. The QA is going to be sitting there, or QA team, wherever it is, going to be sitting there with nothing to do because you've got a load of stuff that needs code reviewing, but the developers don't like doing code reviews. They'd rather write code. So this board is actually screaming at us. So then we get into a situation like this where another developer finishes a piece of work ready to be code reviewed. We've now burst that limit. And QA is like, well, what am I going to do? And this is one of the powers of Kanban because it helps send a visual signal to a team that there's a problem. So in this case, the developers should stop what they're doing immediately and start code reviewing so they can start moving those tickets across to QA. Does anyone use work in progress limits on their Kanban boards? A few, yeah. It's quite rare. I don't see it used that often, but it's such a valuable tool because it's giving a really clear visual indicator what your team has to do at that moment. So, this column is blocked, unblock it, which is great. So there's quite a few differences between Scrum and Kanban. So if we look at the cadence, so Scrum tends to work in fixed sprints, most commonly 2 weeks from what I've seen, can be lower, can be higher. Whereas Kanban is all about continuous flow. So you're not necessarily working in sprints, you're just, you've got a continuous flow of tickets coming into your system, going through all those different columns and then going to done where you deliver it. This is why we have continuous integration and continuous delivery in an ideal scenario. You're constantly pushing these things out. So with Scrum, the release method is typically at the end of a sprint. Now, I know sometimes this is easier said than done in some organisations. I've worked for some companies where you're just never going to get stuff into production every 2 weeks. It's just not going to happen. So in that case, you try and get it into some kind of user acceptance testing environment so the business can at least use the software and learn from it. But with Kanban, again, it's continuous delivery. It's about, you're not putting fixed deliveries out, you're constantly delivering. Scrum has fixed roles or different roles like the product owner, the Scrum Master, the development team itself. Whereas in Kanban, you don't have any pre-existing roles. Anyone can really be expected to help in any area within reason. Worked in one organisation where we had a bit of a problem with QA. Some of them were off sick. We couldn't get stuff tested. A lot of the stuff was manual testing as well as automated. Because it was to do with healthcare, you still have people physically playing with the software as well as automated test suites. And in some cases, we had to get some developers for a week or two just to stop what they were doing and help out the testing team. Obviously, they couldn't test their own stuff, but helping to test other people's tickets, which is quite good. So with Scrum, you use key metrics like velocity as a way of tracking how well your team's doing. So the velocity is the number of effort units, I guess, or the amount of ticket effort you do in that sprint. So if you score 40 in one sprint, you want to be aiming for at least 40 or better in the next sprint. Whereas in Kanban, it's all about the cycle time. So you had our Kanban board. So the time that ticket goes into in progress through to done, that's your cycle time. We looked at cycle times earlier with the value stream maps. Now, typically in Scrum, you strive not to make changes during the sprint. Though it can happen, but if a customer comes along and says we need to make a change, when you finish the sprint, you go back into planning. You replan, re-estimate, and then you start again. Whereas in Kanban, a change can happen literally at any time. Now there is another form of Kanban which is probably one of the most popular ones out there, which is Scrumban, which is exactly the same as Kanban, except if you're using it for a sprint in Scrum, then typically you clear the board down at the end of the sprint, and then you start again with a fresh board. So that's the only real difference between the two. Okay. So those are the main things I wanted to cover. So as a quick summary, so we've got the 7 wastes that we're trying to eliminate from our software development systems and processes. So defects, extra features, handoffs, delays, partially completed work, task switching, and unneeded processes. The principles that we try and work with, that we've spent some time covering today, so value stream mapping, building quality in, amplifying learning, deciding as late as possible, delivering as fast as possible, team empowerment, and seeing the whole when we optimize. So we discussed that Lean is something you use alongside Agile. It's not one or the other. It's something that you can do on top of an Agile development team because it helps you optimize your entire development process. And then we've just looked at some of the differences between Scrum and Kanban. So I hope you found that interesting. It's kind of a primer on Lean. A lot of people, you very rarely hear people talking about Lean when you go into organizations. Everything seems to be Scrum focused. And I think this stuff is so valuable to understand. So if it's something that you do like, then I have some resources for you. So on Pluralsight, I've got a couple of courses that I built. One called Agile Fundamentals. It's a primer on Agile. It's not just good for developers, but if you've got people in the team and you're moving over to Agile, say business analysts, for example, who've never used Agile, this course is good for them. It's a non-technical course. Lean Software Development Fundamentals is another course that I've built, which covers a lot of this, but in more detail with more exercises and examples. I'm also a writer, so I've written several books over the past few years. The Art of Conversation, which is about how to communicate effectively with people, because not all of us software developers like talking to people. It can be quite hard, so this book kind of gives you some tools to make that easier. I've got a book on running businesses called The Path to Freedom, and I've just recently released a book with A-Press called Powerful Presentations, which is about how to deliver messages on stage and in the boardroom. So with that, thank you very much. Maybe have a good rest of the conference. You've got loads of really cool speakers lined up. On your way out, if you could use the voting bins as well. Due to a break in the process, only the green tickets work, the other tickets don't work. So, thank you very much.